All right, so your girls' 1-1 to 1-6 test is going to be on Tuesday. Okay, so we don't have school Monday, so you guys are going to have your tests on Tuesday. I'm going to go over part of this review today, part of it tomorrow. We'll finish it up. Anything you guys have questions on, you need to ask me just to make sure that we're on the same page. I will give your quizzes back at the end of the class period as well. God bless you. So don't fret. But when we talk about this first stuff here, guys, at the beginning, the domain and range, right? Remember, domain, range, increase, decrease, constant. Guys, when you are talking about increase, decrease, and constant, some of you guys lost points on this. You have to use parentheses only. For increase, decrease, constant, it's parentheses only, and we only look on the x-axis. For the most part, you guys did a good job with that. It was just the parentheses and the brackets and stuff kind of got us confused. But if we're looking at, like, question A, right? First of all, do you see specific starting and stopping points? Yes or no? Yeah. Okay, good. So what's the furthest left? What is the domain for this function? It starts at what number? So your domain is -5, and it goes all the way over to what? To 6. Now, look at 1. Do you see there's an open dot and a closed dot? One is on top of each other. That is why the whole thing is included. On your second line, the one to the furthest right, there's an open dot. But right above it is a closed dot. So that means, oh wait, this is included here. So what goes on both pieces here? You're going to have brackets because it's included on both. Good. Now when we talk about our range is from the bottom, the lowest, to the highest. So what's the lowest value on this graph? -4, perfect. Are there any breaks? Are there any places you could say, okay, wait, there's no range values that are on this graph? No, there's no breaks on this one. So it's -4, and it goes all the way up to what number? To 16. Does it include -4? No. Does it include 16? Yes. Okay, good. Now, as far as increase, decrease, and constant are concerned, increase, decrease, and constant. Is there any constant? No, so we can write none. How do we read increase, decrease, constant? From where to where? Left to right. Cross off the y-axis. Remember, it does not matter. We're not even going to look at it. From the left-hand side, your graph is doing what? From -5 to 1. Decreasing. Very good. From -5 to 1. And then what does it do? From 1 to 6. Perfect. Good job. Parentheses only. We don't use brackets because we can't decrease and increase simultaneously. Does that make sense, everybody? We okay? All right, let's do B. We're going to go through B a little quicker. What do you guys notice about the ends of B? They're arrows. What does that mean, my dear? It goes on forever and ever and ever and ever and ever. What's your domain for this function? Perfect. Left to right, -infinity to positive infinity. What is your range from bottom to top? -infinity to what? To 4. Does it include 4? Sure. It absolutely stops at 4. It does not get any higher. Yes, sir.
How do we get 4? Wouldn't it be negative infinity to positive infinity too, or no?
No, it's -infinity to positive infinity is your range. I mean, your domain, because it's going to continually get wider. But it's your range is from -infinity, and it goes all the way up and stops right there. It doesn't get any higher than that. Good question. Is there any constant, guys? So you have increase, decrease, and constant. I always look for constant first because that seems to be the one that we can say, oh yeah, definitely yes, definitely no. From the left-hand side of the graph, if I'm reading, because I'm going to cross off my y-axis, what is going on the left-hand side from -infinity to 0? It's increasing from -infinity to 0. At 0, it turns and starts going which direction? Down, decreasing. So you're decreasing from 0 to what? Infinity. Now, guys, make sure that you understand. I see that arrow is going down, right? Which is where -infinity is. But we only read increase, decrease, constant on the x-axis. So as we go from left to right, it is going down, but it's because your graph is going towards the right, not because it's going downwards. Does that make sense? Okay, let's do C. D is pretty self-explanatory. Let's do C. What do you guys notice about C? Just looking at it, what do you notice? There's a big gap, right? There is a big gap on here where no values exist. So we're gonna have to account for that. So let's talk about our domain. Starting on the left-hand side, what does your domain start with? Negative infinity, and it goes to what? -1. Does it include -1? No. Great. Now there's a big, huge gap. There's a break. So we're going to use the union. That's like saying and. And then where does it pick up again? At 1, and it goes to positive infinity. What do I have on the ends of everything? Parentheses. Very good. Doesn't include 1. And then on our infinities, we always have parentheses. Very good, guys. So now your range. What's the lowest value on this graph? Y equals what? 0. Perfect. And it goes up to where? Infinity, because of those arrows. Does it include either of those? No. Very good. Yes, sir.
So it's infinity because it's not going anywhere lower than the x-axis, right?
Right. Well, it's starting at 0, and then it's infinity because the arrows are telling you that forever it's going to be getting bigger. Yep. Increase, decrease, constant. Is there an area of increase? Yes. Is there an area of decrease? Yes. Is there a constant? No. Good. So from the left-hand side to the right-hand side, let's cross off that y-axis. What is your graph doing from the left-hand side? Moving forward. It's going from negative infinity to what? -1. Decreasing or increasing? Perfect. Negative infinity to -1. And then where is the increase? From 1 to infinity. Good. Very good, guys. Very good. Now, D has a specific starting and stopping point. You guys can handle that. If you have questions about it, you can ask me tomorrow, no problem. All right, now, piecewise functions. Again, work on these tonight if you guys have questions or anything that I don't do, and then come ask me. But I'm going to do letter B. Some of us had a really tough time with our piecewise. I told you guys, don't try to do everything at one time. These two different graphs here, I have y equals -x plus 3, and I have y equals x squared plus 1. First of all, -x plus 3, what kind of a shape is that graph going to make?
Upside down. Like smiley.
Well, hold on. It's to the first power. Straight line. Your x squared is going to make a what, Chris?
I would make a
Parabola. Good. A smiley thing. I like that. Is it a positive? Is it a happy parabola or a sad one? It's happy because it's positive. That means it's going up. All right, so let's talk about our line. I have an intercept at 3, so 1, 2, 3. It's a negative slope. Some of us lost lots of points on a very simple question, graphing a line, because you did the slope wrong. Negative, guys. Show yourself what it looks like. It should be going downward. That's important. Down 1 over 1. So I'm going to go down 1 over 1, down 1 over 1, then up 1 over 1, up 1 over 1. So your line looks something like this. Again, you don't have to do a dotted line. I just am. I know it's easier for you guys on Notability. What does this tell us? What does that parameter tell us? I want all of the values that are less than or equal to -1 on the x-axis. So I'm going to go right here, and I'm going to draw a boundary line. Looking to the left and the right, guys, where are the values less than or equal to -1? On the left-hand side. So from here, I want to keep all this stuff, and I'm going to have a solid dot because it says or equal to. And then what do I do with everything else? You erase it. Good. Good, 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 good. Now we're going to do the exact same thing, but we're going to graph our parabola. So I have x squared plus 1. Guys, you already told me that you should have some sort of a smiley face, a parabola-looking shape. This should not be a straight line. Some of you graphed a straight line. If you don't know what this is going to look like, put in some values. Let's go with, I'm going to say -1, 0, 1, and 2. If I plug in -1, what is -1 squared? Plus 1 is? Perfect. Plug in 0. What's 0 squared? Plus 1 is? 1. 1 squared is? Plus 1 is? Good. 2 squared is? Plus 1 is? Perfect. So plot your points. -1, 2, 0, 1, 1, 2, 2, 1, 2, 3, 4, 5. If we need to go more, you can. But what is the boundary line that I need to take into consideration? Where should I draw a vertical line? Got to be greater than 1. So I'm going to go right here to where x is 1. Where are the values on your parabola bigger than 1? To the right or to the left? To the right. So what kind of a dot do I have at 1? Why is it open? Because it's not included. Good. And it looks something like that. And then what do we do with everything else? We erase it. Did I take off points if it wasn't perfect? No. But some of you weren't even in the same ballpark. And again, I'll show you your quizzes in just a minute. Yep.
Can you erase that last part?
Sure. Like how I got the boundary line?
Yeah.
Okay.
Like the teacher that you did.
So, do you see how this says x is greater than 1? So that's telling me, okay, I'm going to draw a vertical line here at where x is 1. Where are the x values bigger than 1 in respect to that line? To the right or to the left? So that's telling you, okay, you want to keep everything over here to the right side, and then you want to erase everything else. And we can work on more of those if you want to. All right? We okay? Okay, along. No. All right, I wanted to make sure I went over this with you guys today because I know a lot of you had questions. So I wanted to do some of these examples with you, and then maybe you'll be like, oh, okay, that makes sense. Okay, so first of all, let's talk about odd, even, neither. You're going to have one of these on your test. You just tell me odd, even, or neither. You're not going to get any credit for it. I need to see algebraically that you know that a function is odd, even, or neither. So how do we figure that out? Remind me. Tell me.
Plug in any number that's greater than 1.
Okay. Any number greater than 1, and what else?
Any negative number.
And its opposite, right? Okay, so let's first look at our exponent here for letter A. What is the highest exponent you guys see? 1. What kind of a number is 1? It's odd. So my function here is either odd or neither. Agreed? So what number you want to plug in? 2, negative 2? That's fine. So get your problem set up so you can show me all of your work. If I determine that these are opposite functions, or this is an opposite function, what do I write? What word goes in the middle of those two boxes? What are my arrows going in? What direction? Are my arrows going to go in the same direction or opposite directions? Opposite. So when I plug in, and I'm proving if this is an opposite or an odd function, the answer should be opposites of each other. So I'm going to plug in positive 2. So 2 minus 7 times 2. 2 minus 14. What's 2 minus 14? Perfect. So now I'm going to plug in negative 2. So 2 minus 7 times negative 2. 2 plus 14 is what? 16. Are those two numbers exact opposites? So then your function is neither. Yep.
Where'd you get the 2 from?
You can plug in any number, and it's exact opposite, as long as it's bigger than 1. You can do 2, negative 2, 3, negative 3, 10, negative 10. And then you look at the relationship between the two numbers. Like let's look at B. What is the highest exponent that you see? 2. So this is either a what function? Even or neither. Highest exponent tells you the possible outcomes that you could get. So I'm going to plug in 2, negative 2 again. Again, you can do any number you want as long as it's bigger than 1. If I prove that this is an even function, the answers when I evaluate should be what? The same. The direction of the arrows. If it's an odd function, they go in opposite directions. If it's an even function, they go in the same direction. So be careful with negative signs here. You have negative, I'm plugging in 2 squared minus 2. So evaluate the exponent first. 2 squared is? So I have negative 4 minus 2 gives me what? Negative 6. Good. So now I'm going to substitute in negative 2. So I have negative 2 squared minus 2. What's negative 2 squared? 4. So it's negative 4 minus 2 gives me what? Negative 6. What do you notice about those two answers? They are the same. So you just proved that this is what kind of a function? There you go. Does that make sense, Sophia? Okay. All right, look at C. Some of you guys are like, oh, I don't know. Well, what is the exponent on this function? It's actually 1/3, but it is an odd root. I agree. So what are the two possibilities that this could be? Odd or neither. Okay, I'm going to plug in 2 and -2. Again, you guys can use any number you want as long as it's bigger than 1. If I think this is an odd function, my answer should be what of each other? Opposites. Good. All right, so I have the cube root of 2 minus 1. The cube root of 1 is what? 1, okay. So over here I have the cube root of -2 minus 1. So I have the cube root of -3. Anybody know what number of times itself 3 times gives you -3? What do you know it's not? It's not -1, right? Could you take the cube root of -1? Yes, 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 yes. What number of times itself 3 times gives you -1? -1. Are these two things exact opposites of each other? No. Even though you don't know what the cube root of -3 is, you do know that they are not what of each other? Opposites. So it's neither. Say you get a question like this and you're like, ugh, I'm not really sure. I'm confused. Try a different number. Let's try 3 and -3 and see what happens. I have the cube root of 3 minus 1. So the cube root of 2. You guys agree? Okay, so then over here I have the cube root of -3 minus 1. So the cube root of -4. Guys, are those two exact opposites of each other? No. So don't get hung up on, I don't know what the cube root of 2 is. That's fine. Remember, it's not the actual answer. It's the relationship between the two. That's what's the important part. That make sense? All right, so yesterday you guys talked about combining functions and then composite functions. Yesterday and the day before. I think the combining part is pretty simple, right? They're going to give you functions. Here's the f function. Here's the g function. In letter A, what are they asking you to do? Add the two together. In letter B, what are they asking you to do? Subtract. But how is the first one different from the second one? Okay. If you guys have something in terms of x, what letter should be in your answer? An x. If you have something in terms of a number, you should have a number answer. So in letter A, all they're doing is saying, okay, take the f function, which is 7x minus 6, and add it to the g. You're just combining like terms. So 4 minus x. You guys agree? Since we're adding, we don't have to distribute negatives or anything like that. So what is 7x minus 1x? 6x, and then -6 plus 4. -2. There you go. That's it. If you have an x, like f times g of x or something, if that means keep it in terms of x, you should have an x in your answer. So when we are subtracting, that's when we have to be careful, right? These are two separate questions, so treat them separately. The first one says take the f function, which is 7x minus 6, and subtract the g, correct? So be careful, guys. If it said g minus f, then you have to put them in the correct order. Subtraction's a little different because I have a subtraction sign there. What do I have to do with that negative sign? I have to distribute it. So 7x minus 6 minus 4 plus x, correct? So now when I combine, 7x and 1x is 8x, and then -6 and -4 is minus 10. Good, right? What B is saying is to subtract the 2, but for all the x's, plug in what number? 0. Now, there's a couple different ways you could do this. You could say, okay, 7 times 0 minus 6 minus 4 minus 0. And I'd get -6 minus 4, so I get -10. You guys agree? Well, how else could I have done that? Could I have just plugged in the 0 right here after I already combined it? Sure. Whichever way you guys would like to do it, that's fine. If you want to combine the function first, then substitute in, or if you want to substitute in throughout, it does not matter. But look, if I plugged in 0 there, I would have gotten -10 as well. That makes sense? All right, let's go to multiplication. So f times g. So 7x minus 6 times 4 minus x. Should I have an x in my answer here, or should I have a number? I should have an x, because it says in terms of x. So guys, all we're doing is foiling. What's 7x times 4? 28x, good. 7x times negative x. Perfect. Negative 6 times 4. Perfect. And negative 6 and negative x. Plus 6x. We have to combine like terms. We need to write in standard form. So what should come first? Good. So I have negative 7x squared. Perfect. Can I combine anything? 28 and 6. Perfect. Minus 24. Good. Very good. All right. And then f divided by g. What goes on top? The f. 7x. Good. Minus 6. What goes on the bottom? 4 minus x. Guys, is there anything you can do here? No. How come I can't just cross off the x's? Right. Look at this. 7x and negative 6, they are joined in holy matrimony in math by parentheses and by a plus or minus sign. There is no divorce in algebra. Cannot. If this was just multiplication, absolutely. But since they are joined in union by a minus sign, you cannot break them up. Now, if they ask you for the domain, why is there a domain restriction here? There's an x and a denominator. So you have to, whenever you guys have either a root, square root, or if you have a denominator, that's when you're going to have to say, okay, wait a second. There's some values that I can't use. How could I figure out what I can't use? Perfect. Set your denominator equal to or not equal to, however you want to say it, 0. So if I solve this, I'm going to subtract 4 from both sides. So negative x, negative 4. What is the only value that I cannot use? X cannot be positive 4. So to write that in grown-up terms, because we're not going to write just x can't be 4, how would I write I can use any number in the whole world except for 4? Negative infinity to, Yep, perfect. Perfect. You're telling me I can use any number in the whole world except for 4. Perfect. Good job. All right, I'll go over 5 tomorrow. You guys can work on it tonight if you want to. I'll go over, make sure you guys know how to do it. But I want to get to some composition ones. We'll come back to it, though. You guys all right? Okay, let's talk about some composition of functions. And then we're going to, I'll give you your quizzes back. Composition. Guys, if you have a composition, it's something is made up of something. Right? I talked to you guys about this in the video. And again, I know it could be a little confusing. That does not say fog. It does not say F times G. It says F of G. Sometimes it's written like this. Sometimes it's written like this. F, G of X, like this. What I want you guys to understand is you're taking one function and plugging it into another. Remember to work inside out. That is the most important thing. When I say inside out. Inside out. Whatever is closest to the x. Look, you're taking the g function and you're doing what with it? You're plugging it into the f function. Draw yourself a picture. Watch. Take the g function and plug it into the f function. Show yourself exactly what you're doing. So in a case like this, I have the cube root of, instead of x, guys, what am I plugging in? X cubed, what? Plus 1. And then I finish the rest of the f function, so it's minus 1. Now you use your algebra. Can we simplify anything here? Yeah. What can you simplify? 1 minus 1 is 0, so this becomes the cube root of x cubed. Well, when you cube a cube root, it just becomes x. That's it. That's a totally acceptable answer. So B is not saying the same thing. B is saying the opposite thing. B is saying to do what? Take the f and put it into G. So I'm going to take this whole f function and plug it in right there. So instead of the x, I'm going to write, okay, cube root of... I'm going to take that whole f function and I'm going to plug it into the G. So I have cube root of x minus 1. Come on, x minus 1. And then cubed plus 1. If I'm going to simplify this, guys, what happens when you cube a cube root? It cancels. Then you're left with x minus 1 plus 1. Now what happens? These two cancel, so you're left with what? X. What you guys just proved, which you don't need to know right now, we'll talk about it a little more tomorrow, but you prove that these are inverses of each other. When you take one function and plug it in, and then vice versa, and you get x both times, you just prove that they're exact opposites. But what are they asking you to do in C? Watch, circle it. They're telling you to, okay, plug 0 into G. Then what do you do with that answer? You plug it into the F. So do this in 2 steps, guys. Find G of 0. Plug in 0 into the G function. So I have 0 cubed plus 1 is what? 1. So now I'm going to take 1 and put it where? Into the F. All you're doing when you have a composition and you're using a number, you're taking one function, plugging a number into it, then whatever answer you get, you plug it into the other one. It's just 2 different problems jammed into one. So this is now the cube root of 1 minus 1. Agreed? Okay, so, well, what is 1 minus 1? What's the cube root of 0? Okay, so the cube root of 0, what number times itself 3 times gives you 0? 0, yeah. All right, so same thing here, guys. A and B does not say golf and fog. What? All right, this says f of g of x. Think about it like this. We're going to work from the inside out. You're going to take the g function and do what? Plug it into the f. Draw yourself the picture. Take the g function and plug it into the f. So instead of x, I'm going to write 1 over x, and then I finish what that original f function is, so it's cubed. How do I simplify this, guys? I have to distribute. Where does that 3 go? To where and where? To the numerator and the denominator. So this is 1 cubed is 1 over x cubed. Perfect. So letter B says g of f of x. It says take the whole f function and plug it into the g. So I'm going to take the whole f function and plug it into the g. So 1 over, instead of x, I'm going to write x cubed. Is there anything else I can do there? No. Absolutely not. What's the domain? Can I just use any numbers in the whole world that I want to? What number can I not use? Why? Because your denominator would be undefined. So how would I write, hey, I can use any number in the whole world except for 0? Negative infinity to 0. Union 0 to infinity. Perfect. Very good, guys. And then what is f of g of 0? Think about it. If I plug in 0, if I take the g, it is undefined. I get 1 over 0 cubed, which is no bueno, right? So be undefined. We'll work on a few more of those tomorrow, I promise. I will finish the rest of this review tomorrow. Distance, midpoint, slope, parallel, perpendicular, that sort of a thing. And what else is on there? Inverses. Switching x and y. Hang on one sec. But I will finish this tomorrow. I will make sure it's uploaded so you guys have it, and then you can ask me questions tomorrow.